All right, let's jump right in and tackle a question that pretty much every network admin has to deal with. How do you give your guests Wi-Fi access without, handing over the keys to the entire kingdom? Today, we're going to break down how this works inside a Cisco SD Access environment. We'll explore the two main models for Secure Guest Wireless, which should really help you figure out which one is the best fit for your network.
So here's our game plan. First, we'll set the stage with the core challenge of guest access. Then, we'll dive into the modern SD Access native guest solution. After that, we'll look at its more traditional cousin, the anchored WLC model. And then, the really cool part, we'll see how Cisco DNA Center automates the whole thing. We'll wrap it all up with a side-by-side comparison to make everything crystal clear.
Okay, let's get into our first section. We're talking about that fundamental challenge, that constant balancing act between making things super convenient for your guests and keeping your own network absolutely bulletproof.
I mean, this is the big one, right? The million-dollar question. You have to provide internet for your visitors. It's just expected these days. But at the same time, you cannot, under any circumstances, risk exposing your internal servers or your company's private data. If you get this wrong, that simple convenience turns into a massive security hole. It is a classic high-stakes problem.
So how does Cisco's SD Access help solve this puzzle? Well, let's start with the modern way of doing things, the SD Access native guest solution. Honestly, this is a real game changer because it builds guest access right into the fabric architecture itself, which makes it incredibly simple and secure from the ground up.
The key word to focus on here is native. This whole solution leverages the power that's already built into the SD Access fabric. We call it a one-touch setup because DNA Center automates pretty much everything. And here's the best part. You don't even need a dedicated Anchor WLC for this to work.
This diagram shows you exactly what's happening under the hood. So, follow the flow with me. A guest connects to the Wi-Fi. Instantly, all their data gets wrapped up inside a secure VXLAN tunnel. A good way to think of this is like a private express highway built just for them, running right over your existing network. That private highway goes directly to a dedicated guest border node, which then shoots the traffic straight out to the internet. The guest data is totally isolated. It never even merges with your internal enterprise traffic.
And that right there, that is the magic of the native model. Because that guest traffic lives inside its own private tunnel from the very beginning, you get complete separation of not just the data, but the control plane as well. It's literally like having two completely separate networks running on the exact same physical infrastructure. That is a huge win for security.
Okay, now let's switch gears and look at the more traditional approach, the Anchor WLC solution. This is a tried and true method, a staple in networking for years, and the great news is it's also fully supported and automated within an SD Access environment.
I bet a lot of you are nodding your heads right now because this is a very familiar architecture. The concept is straightforward. You place a dedicated Anchor wireless LAN controller in your DMZ. Then, any guest traffic, doesn't matter where it originates on your campus, gets tunneled from your internal foreign controllers to this one single hardened exit point.
And this slide brings that architecture to life. You can see it right here. A guest connects, their traffic hits the internal foreign WLC, and from there, a secure Ethernet over IP, or EOIP tunnel is built through your network, all the way to the Anchor WLC sitting in the DMZ. This tunnel is really the key piece that contains all that guest traffic and keeps it safely walled off from all your internal resources.
So this model uses that special EOIP tunnel to create what we call logical path isolation. It's what allows you to apply completely different security rules and quality of service policies for your guests. It is an incredibly reliable and proven solution. And for any organization that already has this kind of architecture, it's a fantastic way to protect and extend that investment right into a modern SD Access fabric.
Now for the really great news, it doesn't matter which of these two models you decide to go with. Cisco DNA Center automates the entire setup. What used to be a really complex, multi-step process on the command line is now a simple, guided workflow that saves you a ton of time and, just as importantly, prevents configuration errors.
The whole process starts right here, in the network settings workflow. Instead of typing out line after line of code, you just walk through a simple three-step wizard. The first step is just defining the basics. You give your guest network its SSID name, you set a security level, and you tell it which authentication server to use, like Cisco ISC.
And if you're using the Anchor foreign model, this step is where the real power is. When you're provisioning a new WLC, you simply tell DNA Center what its job is. Is it going to be a foreign controller inside your fabric, or is it the guest Anchor sitting out in the DMZ? With just that one click, DNA Center goes and builds all the complex configurations, the mobility groups, the tunnels, everything for you.
That is the power of intent-based networking in action. Okay, so we've looked at two very powerful options, and we've seen how to automate them. So the big question now is, which model is the right one for you? Let's put them head-to-head to make that decision just a little bit easier.
This table really lays it all out for us. You can see the core difference right away, the tunneling technology. It's either the fabric-native VXLAN or the traditional EOIP. That choice then dictates the key piece of hardware you'll need, a dedicated border node for the native model, or that Anchor WEL-C for the, well, Anchor model. And of course, that changes the data path and ultimately the kind of separation you get. The native model gives you that complete clean slate network separation, while the Anchor model provides that powerful and proven logical isolation.
So how do you choose? Well, it really boils down to this. If you're building a brand new greenfield SD access network and you want the absolute most streamlined, deeply integrated solution you can get, the native guest model is an amazing choice. But if you already have an Anchor controller architecture that works really well for you, the Anchor Foreign model is a fantastic, fully automated way to protect that investment. The right choice really just depends on your specific needs, your security posture, and where you want to take your network in the future.